Hi, today I want to talk about the task analysis, user experience design, and privacy and ethical considerations for the smart spend optimization project. With regard to the task analysis, our company needs to reduce internal spending to optimize the financial performance. The smart spend optimization project shall motivate employees to cut spending on equipment, travel, and other internal costs, while at the same time keep employee engagement as high as possible. So the key task is to optimize employee spending by utilizing personal recommendations, and these recommendations will be created by a machine learning application that is trained on typical spending patterns in our company. In addition, we will also integrate feedback mechanisms to further improve the performance of the applications. The user currently has to perform the following task. If a user adds an expensive item to the shopping cart, there will be an information warning or error message, and the user then has to first to understand the cause for this message, which guideline this item is violating, and with this information the user has to search manually for alternatives. So the user has to set up this search criteria or filter, and once the user thinks he has found a valid alternative, he will add the found item to the shopping cart and remove the previously added invalid item. And then the user has to trigger another validation and see if this new shopping cart is valid. As you can see, there's room for improvement. Of course, the data for we will collect any usage data automatically in the background for the training. But with regard to the user interaction and the user experience, we aim for a fully automated solution. That means that the invalid items should be replaced almost automatically from the shopping cart, at least with minimal interactions from the user. But still, the user should be able to see explanations and should why an item will be replaced. So it should just see confirm a change. A further improvement could be the addition of an intelligent chatbot. This chatbot will then magically create a valid shopping cart from a textual user query. So the user will describe what he's looking for, and then the chatbot will generate the proper shopping cart. Further recommendations for our process are, as mentioned before, the feedback mechanism, like and dislike mechanism for the recommendations. And for textual feedback, we would need to implement a sentiment analysis. Further details on the user experience design. The cost-saving alternatives shall be displayed as early as possible. So already, if the user wants to add an invalid item, but latest points directly after adding the item to the shopping cart, and then also the alternatives can be selected and replaced, and also at that time the user should be able to get a feedback how he is contributing to the company goals with regard to cost optimization. Then we also will show on this page the quick feedback buttons, like and dislike, and on demand the textual feedback option if a user wants to provide more feedback. With regard to transparency, there will always be a short explanations why a suggestion was made. For example, that a hotel alternative is cheaper than the other one, but it provides the same quality of service. And we are also documenting, of course, the factors that are influencing the recommendations, and this is also information we will show to the user. With regard to uncertainty, we will, if the machine learning application is not sure about the best solution, there will be more than one alternative, and the user can click through the alternatives, a few, and select the best one. From this information that is also used, stored and used for the training we offered, we hope to be able to improve the suggestions in the future as well. Now with regard to privacy considerations, so yeah, the data that we collect can be viewed as personally identifiable information. So a spending pattern together with other data could be used to identify the user, and that's why we think it's very sensitive data and care has to be taken. We only want to collect the data that is really required for its application, for our application and its optimizations. And of course, we will ensure that we will use anonymized data only. Privacy laws that are applicable in the European Union. GDPR is applicable, and in the US we will have to follow US state law with regard to that. Users have the right to opt out from the process, or have the right to see their data, download their data, or delete their data from the applications. This will be supported. That's potential sources of bias. We can think of 3 different bias. Representation bias, of course, that could be in the data. If we do not collect the data right, there can be some groups that are amplified. For example, there might be different requirements for spending between developers and product managers, or managers in general, and care has to be taken that the models are balanced between the different roles, departments, or locations. And there could also be some kind of measurement bias. For example, that could spoil our goals of cost reduction if we just take into account the initial cost and not the total lifetime cost. The machine learning application might not be able to improve our company financial performance in the long term. Representation bias is also possible. The data that could also be used to remove certain items from the catalog, and that is currently not intended initially. So ethical considerations, so the fairness, we will perform regular audits for the models to check for bias, and the results of these audits will be used to improve the model. Accountability and transparency, for both we will make use of data sheets for data sets, and for our models the data sets will contain all the required information about the model performance, the updates, potential biases, and also the responsibilities, so that if we get the feedback, we can also route then the feedback to the responsible models or dataset owners, and also the end users can use the data that is derived from these data sheets, because we want to share this information on the documentation, so they can learn how the models have been trained, how the recommendations are derived from data, and explain potential sources of bias or the limitations of the models. Thank you.